small over big, and you cross multiply. Okay. So let's go to number 8. So 4, 5, 6, 7, 8, 9, 10, 11. All of those are proving triangles are similar using one of these three things: side, 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 angle, or angle, angle. So if we start at number 8, just by looking at on the EOC review that I gave you on Monday. Hey, are you here for our stuff? Those are extra blue sheets. There's another one, or yellow sheets. If you, I don't know if she wants this back or not. Oh, and she does. There was already one missing, so I don't know. They're both missing.
I don't think they.
No, they're not taking it fast. Okay, so for number 8, do you have any sides? No. So automatically this would have to be angle, angle, but this is actually a little trickster in here. This one is not similar. Does anybody know why? That actually did. The angles do not match. If you actually do the math, if you take 180, because a triangle adds to make 180, if you take 180, you minus the 90, crap, minus 90, and then you minus 29, you would get 61. So if that's 61, this one's 64. So is this similar? No. So this is actually not similar, but if it was similar, it would be AA. But the angles don't match. So that's the only one that's like a little trickster in there. The rest are similar. Yes, this is what you got on Monday. So yeah. So for number 10, this one's a little weird because there's no numbers. There's also no angles. So you're just like, what's going on? You should automatically know which angles automatically congruent to each other. Which one's the same? L, because vertical angles are congruent. And then they want you to know what these little arrows mean. Does anybody remember what those arrows mean? They're not congruent.
Like that.
Nope. They're parallel. So that means that these two lines will never cross. So what this is involving is parallel lines cut by transversal. So this is like, if this one's my transversal that I'm talking about, you could technically say N is congruent to K because of alternate interior angles. It jumps across the transversal, parallel lines cut by a transversal. So what theorem would this have to be? Angle, angle. There are no sides, so you cannot use sides at all. Sides are on the outside. Sides would have to give you a length. And then the last question that you guys had on this one was number 12, right? Okay, so 12 is the Pythagorean theorem. So this one's a little weird, but it's not terrible. It's just a little confusing. It says which side lengths form a right triangle. So for it to be a right triangle, you have to use a squared plus b squared and c if it actually equals to c squared. Okay, so a and b are the smallest side. This one's the longest. So if I choose the smallest numbers out of option A, what are my two smallest? So I'll call this A, I'll call this B. 34 has to be C because it's the largest. So does 16 squared plus 30 squared actually equal 34 squared? I think you end up getting like 1,100 and something. So what's 16 squared plus 30 squared? 36?
Yes.
56? And then 34 squared equals 1,056 as well. So this one forms a right triangle because it actually forms. The other ones you just need to check. If it's not equal, then it's no. Okay, let's go to actually today's paper. Today's paper is a classwork day. So let's look at the problems. You can cross out these ones. You're turning this in. Which one would you like to do? Which one looks hard? We learned about 3 things yesterday. If they cross on the inside, like this, you add. If it crosses on the outside, you don't have to draw this.
Wait, what did we learn yesterday?
You subtract, and if it's on the side, you just divide. So which one looks hard? Number 6? Okay, we'll do 2. So let's start with 6. 6, which one does it look like? The addition, the subtraction, or just the division? subtraction because it's got a little nose. So this one we're doing big arc minus small arc divided by 2 equals the angle. So this is my big. First thing I need to do is find big arc because there's nothing out there. Yep, a circle makes 360. So if this is 108, how much is big arc if it makes 360? How much is it? 252?
Yeah.
Okay, 250. That's okay. No. It's not 252. Like, what's if you subtract from 3? Is it 252?
Yeah.
Oh my God, I'm having a brain fart. I'm sorry. So this is small arc. So what are we gonna do with big arc and small arc? Subtract it. So 252 minus 108 divided by 2. What do we got? 72. Well, that was easy. Can we pick a harder one? No. Let's go to 14. 14. That's a hard one. The ones towards the bottom are the harder. Okay, so let's go to 14. 14. Okay. You have 3 options. You have the addition, which crosses on the inside. You have the subtraction, which is on the outside. It looks like a bird's nose. And then you have on the edge. So for number 14, that looks like this. We're not adding or subtracting. Okay. All we're doing is dividing because every single problem involves dividing. This one, we're not adding or subtracting anything. So let's start by putting the stuff on the picture. So WVX. Wait, WV. Oh yeah, WVX is 13x plus 9. The angle is 5x plus 36. So which one am I dividing by 2? Am I dividing 13 by 2 or 5 by 2? 13. It's always the arcs that get divided by 2. So I'm going to take the arc, I'm going to divide it by 2. I'm going to equal it to the angle. So there's 2 things that you could do at this point. You could get rid of the 2 by using multiplication to the other side. Most people are just dividing it. So 13 divided by 2 is 6.5x. What's 9 divided by 2? 4.5. And now it's a regular, good old math problem. So take a second, you're going to subtract to both sides. You're going to have decimals like throughout the process if you choose to divide. But in the end, it'll end up being a whole number. And all your decimals you get are 0.5s because you're cutting everything. You're so what? Oh. That's not right. Mm-hmm. Let me just mumble it. Yeah. So if you minus, and then you minus, you get x is 21. Now I gotta plug it back in. My goal is to find WXY, so you have to kind of be a little careful about where you plug it back into. WXY is an angle. WXY is over here though. So we got kind of like a problem. So if I plug it into this, that's not going to be the answer. I'm going to have one extra step. So if I plug 21 in, 5 times 21 plus 36, how much is this big angle? 141. So if this is 141 over here, how do you find the angle next to it? Subtract from 180. So the final answer is how much? 39. Would you like to set up one more? I'd like to set up number 15 because that one's the hard one. So 15 is right after this one. This one we're going to set up together as well. So take a second, put your stuff on your picture. Bless you. So we're going to subtract because the point where they crosses on the outside. Yep. So we're gonna take big arc, we're gonna minus small arc, we're gonna divide it by 2 because the arcs are always getting divided by 2, and it's equal to the angle. So it's gonna look a little cray, but it's okay. 27x plus 3, and then I'm minusing small arc. So this is the little trickster. We did this yesterday. You're minusing everything in the small arc. So you do have to be careful. This is the only problem that does this on this paper. Divide by 2. And then it's going to equal the angle on the outside. So when you subtract to combine like terms, 27, you're subtracting 9. How much is that? 18x. And then you have to remember you're doing 3 and you're subtracting -5. 8. So it ends up adding. So this is the only weirdo that does that because you're doing 3 minus -5. And if you look at your picture, you're doing 3, you're subtracting -5. So it's really adding. So 8. And then you would divide each by 2 and then you would solve like normal. So let me know if you get stuck. Let me know if you get something crazy. When you're done, you're going to turn this in and then make sure you're working on your EOC review because I'm going to collect tomorrow. If you don't finish the classwork, you can turn it in tomorrow. That's fine. But like realistically, you should be able to because you're skipping 2. You can cross out 7, 8, 16, and 2. And then I'm going to come around and see your paper from yesterday. You